Welcome to a lesson with Dr. Powell. Let's take a look at how we can visually see what an adjacency matrix and a power of it look like just from the digraph. Okay, first, the adjacency matrix. Look at the first column. This is data, which represents paths into vertex 1. There's one path from vertex 1 into itself, one path from V2 into V1. Here, for V2, there are two paths that go into it from V3. Here, for V3, there's one path that comes into it from V1 and one path that comes into it from itself. Okay, now for A squared, what does this represent? Well, this is a module map from Z4 to Z4. And if we compose it with itself, we get this one. The question that this map answers is how many paths from where go into a collection of vertices, at least when those paths are one arrow length long. If we compose this map over twice, it answers the same question, but for path arrows that are 2 length long. So to get this one, we simply look at paths into vertex 1 that have 2 arrows in them. So let's think about that. Vertex 1. There's one path of length 2 that goes into it. And from V1, V2, let's see, that comes from V2. There's a path, let's see, here and then around. That's 1. One path from V2 into V1. Here, that's length 2. And then here, let's see, this 2 means there must be 2 paths of length 2. Let's just check that come from V3. Let's see, from V3, you can go this one, or that one, that one. Yes, that works. Let's look at the next one, paths into V2 of length 2. Let's see what we could do from V1. We could go here, here, or here, here. That's 2. Now from V3, we could go here and then there, or here and then there. That's 2. From itself, there's nothing. You could go away this way, but any arrows that you go further won't get you back to V2, so nothing of length 2 that starts at V2 and ends at V2. Now for V3, let's think. We have coming from V1, we can go like this, and then like that, or we can go like that and then like that. Hey, that's 2. All right, now from V2 into V3, we can go here and here. That's 1. From V3 of length 2, you could go here and here. Hey, that's just 1. So we're done. That's A squared. Now, let's just double check to make sure the matrix multiplication worked here. If we say this times this is that. So to matrix multiply this by itself, we could do column by column. So take this matrix and multiply it to its first column. That's going to be the first column over here. And how do we get it? What does that mean? Well, it preserves structure, and this is the image of V1, this is the image of V2, and the image of V3 in this map. And so really what we're doing is we're going to be adding the image of V1 plus the image of V2, which means adding the first column and the second column together. So 1 times the first, 1 times the second column, and you get 1, 1, 2. Hey, that looks like that. That's just what we wanted. Here, to get the second column, we simply matrix multiply this to the second column, which means add up 0 times first column, 0 times second column, plus 2 times the last column. So just 2, 0, 2. Hey, that's what we got. Great. Now, what does this mean? This just means add the first and the last together, columns. And so you end up getting 2, 1, 1. Yes, it worked. So we were able to visually see what A squared looks like just right on the digraph itself. Thanks for watching.